All right, so what we're going to do is look at the May-June 2022 paper. And what I'm going to do is some of the questions, of course, like you guys know, when you go from 1 to roughly question number 20, they're not very tricky. There's not effort that's needed there. And most candidates can handle those well. But during the 1 hour, we'll try to cover as many as we can. The point is to just share with you how I would advise you to work through the questions and how I would do that myself. So when we look at question number 1, we have a force of 3 Newton and force Newton acting on an object, and they're saying what's the maximum possible resultant. So this one's again pretty straightforward. We know that when both the forces are in the same direction, that is where you'll get the maximum resultant force because they're both assisting each other. So that's the 7. And one other thing that you might want to note is that if they had asked you about the minimum possible resultant, then you'd have forces going in the opposite direction. And the answer in that case would be 1. Number 2, we just have 2 measurements, length of 0.5 and diameter of 0.5 millimeters. So the length is 0.5 meters, diameter is 0.5 millimeters, and they're simply asking what instruments we can use to do the measurements. Now, one thing that I would very strongly recommend is that most students do not make good use of the paper, which basically means that they're trying to do a lot of the working in their head. The fact that you have a paper in front of you and you can do rough working, you need to use that to your advantage. And the way to do that is just underline all the key details that are there in the question so that consciously you know what you need to look at and you're not thinking about too much stuff in your mind. So it'll make the process a lot easier for you so that you don't have to read the whole question again and again in case you're thinking about a question. Well, this is 0.5 meter, right? And this one, the second one, diameter, is to the nearest 0.01 millimeter. And that hopefully, this part here, the precision just reminds you what the instrument needs to be. 0.5 meter, definitely the meter rule would work well for that. 0.5 millimeters is going to be very suitable for a micrometer. And again, if in case somebody is not 100% sure about something like this, then again, the most obvious thing you want to do is eliminate answer choices. For example, in this case, you know that the length of 0.5 meter is far too long for calipers to handle. So you can easily eliminate C and D. Again, that's really going to help you, particularly in the case where you're not too sure about what the answer is. Now over here, we have a speed time graph, and they want to know where's the point where he opens the parachute. So when the parachutist deploys the parachute, we know that the key thing that's supposed to happen is that he's basically falling downward. And the acceleration at the instant where he opens the parachute is in the upward direction. So when acceleration is opposing the direction of motion, what that means is that the person is going to decelerate. In other words, we know that finally the result of this will be that the speed should start decreasing. And of course, that's happening at B. Hopefully that should not be a problem as well. And by the way, if you want to ask something, just let me know. Question number 4, a 60 kg passenger enters a stationary lift. Value of G is 10. So we'll underline both of those. How much force? We're going to underline that as well because that's the unknown we're looking for. How much force does the lift exert on the passenger when the lift accelerates upwards at 2 meters per second squared? Now, another very effective thing you can do on P1 or even actually P2, but right now let's just stick to P1, is that you mark all of the quantities given and use symbols that you do in the syllabus. That's F, that's M, that's G. F is the unknown, so you put a question mark there, and this is the acceleration. Now, just by doing this, you see, without going into details of what the question is all about, I do know that, okay, I have to find F, but I know the mass and the acceleration. And then F, M, and A, it again makes it very obvious what the equation is, which is F is equal to MA, right? Now, in this case, this is a very good example of a question where you should bring a diagram into the picture. So just a very simple sketch where we draw a person standing on the lift. We say, okay, what's the downward force? That's the weight, which is going to be equal to mg. And the lift will exert an upward force. Let's call it F up. And therefore, because of these two forces, he's going to accelerate at 2 meters per second upward. So they're saying the lift is accelerating upward. We know M, we know A, so we're going to use this equation. F is equal to MA. F is the resultant force. So it needs to be the upward force minus the downward, which is the weight, and that is equal to mass times acceleration, which is 2. So upward force, the weight is 600 because M into G, so just 60 into 10, that's 600. If you solve this equation, you'll get 720 newtons. That's the upward force. So your answer would be D. Now, one thing is that, why are we doing F up minus W, meaning upward force minus the weight? Why are we not doing the weight minus F up? The reason for that is that we already know that the acceleration is in the upward direction. So according to Newton's second law of motion, F is equal to ma, direction of F and direction of A are always the same. So we already know that the resultant force is in the upward direction. That's why we're subtracting the downward force from the upward force, and we'll end up with a positive number. If you were to switch the two, if you were to do weight minus the upward force, then in that case, you'll get a negative result here. But the magnitude will still be correct. So even if you did that by mistake, you'd still, but you know, when you have to be careful with the signs. And how do you do that? You just remember that A and F are always in the same direction. Number 5 is really easy. So it's just, they're saying, where is the direction of the resultant force? In case of circular motion, it's always towards the center of the circle. And again, one thing we can note from this question, which is very important, is that again, A and resultant force F, they're both going to be in the same direction. So if they were to ask you about acceleration, which they do very commonly, it's still going to be towards the center. Okay, so 6, positive, negative. Okay, just a small correction. So if you were to do weight minus upward force, you'd actually end up with the wrong result. And I want to show you that. Weight is 600 minus upward force is equal to M times A, which is 120. So you see, if you were to do that, you'd actually end up with 480 newtons. And there you go. You'd pick the wrong choice. So know which one's upward, which one's result is upward or downward, and then you use that information to do the actual problem. So don't jump right into it. What's a dense block that has some weight acting on it and a force here as well? They're saying, what is the horizontal force that just makes the block start to rotate about P? Now, when the block starts rotating, what does that tell you? That that's exactly the point where the principle of moments will apply. Just before it starts rotating, the clockwise and anti-clockwise moments are going to be the same. Now, again, whenever you're doing a moments problem, I'll tell you exactly how you should do it. The first thing you should always do is draw arrows that show the direction of the moment of each force. So for example, the 50 Newton force here, the weight, is going to create a counterclockwise moment. The force F is going to create a clockwise moment. So what I'm going to do is draw both of those arrows. Why am I doing that? So that when I'm solving the question, I don't mix them up. So all we need to do is the clockwise moment should be equal to the anti-clockwise moment. So clockwise is F, and it's 40 centimeters away from the pivot. So that's 40 times F. The counterclockwise moment is 50, which is the force. And how far is it from the pivot? It is this horizontal distance. That is 4. So 50 times 4. And if you do that, you'd get 200 divided by 40, and that gives you 5 newtons. One other thing you want to be careful about, which often creates confusion, is that F into D, the equation to calculate the moment. Over here, D is always the perpendicular distance between the line of action of the force and the pivot. What that actually means is that when you draw the line for F and you draw the distance on the diagram, the line for F and the line for D, they should always make a 90-degree angle. If they don't, that's a hint that you're using the wrong distance. Number 8 says, in which arrangement is the center of mass the lowest? So we just need to think, okay, what's the position in which we can put this cube where it has the lowest height? Because if it has the lowest height, then the center of mass is going to be lower. Why is that? Because all of the mass is now going to be at a lower height, and it will just pull the center of mass lower as well. If we put it on face Y, if face Y is the one that is on the table or the desk, then you'll see that this side will act as the height of the object. And that's going to give you the lowest height. That means that is the direct position in which you'll get the lowest center of mass. And let me show you something else as well. If you were to put it like this, for example, and if I move this up to align it with the original direction, right there, you see, this one now has a greater height than the original position. So in this case, the center of mass would actually move higher. But in this question, they want us to go lower. And generally speaking, what happens is that wherever there's more mass, that's where the center of mass will shift. So if there's more mass above a certain line, then that means the center of mass is going to move upward. Okay, number 9, which point is the limit of proportionality? That's pretty straightforward. It's C. Why is it C? Because the limit of proportionality, the word, what does that mean? In very simple words, it means that what is the point where proportionality between force and extension ends? And it ends where the straight line section of the graph ends. So if I were to just extend that, you can see that it begins curving at C. So that's it. And what does it mean? It means that beyond this point, so to the right of this region, force and extension are no longer proportional to each other. Whereas in the straight line section, they are. And that's exactly what Hooke's law says, that extension is directly proportional to F. And the equation for Hooke's law is F is equal to Kx. Finally, another thing you can note from this question is that this is the region where this equation applies, just the straight line section. So be mindful of that fact. You cannot apply it beyond the limit of proportionality. And I think it's worth mentioning, the reason why I'm going in this manner or discussing it like this is because, you see, this is one question in isolation, but you can use it very effectively to review certain things. For example, this part, extension, and that it applies only in this section. There's a lot of value that you can take out from it when you're preparing, particularly in the final.